Welcome to this tutorial on Lambda function in C# scripting in Unity. A Lambda expression is defined in computer programming as an anonymous function, which are functions without a name. Most people will be familiar with this mathematical syntax to define a function: f of x equals to x multiplied by x, where square of x is equal to x multiplied by x. Both the function called f and the function called square take the value of x and compute the square of that number. Both functions perform the exact same computation, so both functions will have the same corresponding lambda expression. The only difference is their name, hence anonymizing them yields the same result. The exact mathematical definition of functions doesn't really matter here. It suffices to understand that a function, and hence a lambda expression in computer programming, is an object that, given an input, produces an output. Here, given x, the input, x multiplied by x, will be computed, the output. So if the input is 2, the output will be 4. Now that we know that lambda expressions are anonymous functions and what that means, let's see how these are used in programming. Lambda expressions are used in programming to make code more easily readable. They are useful when the function is short and simple, and defining it separately and giving it a descriptive name is not necessary. In C#, we can write a lambda expression that computes the square of its input with this syntax. There are two kinds of lambda expressions. Expression lambdas are lambda expressions where the body, the right-hand side, is an expression, such as x multiplied by x in the example we saw earlier. Statement lambdas are lambda expressions whose bodies are blocks of code. Let's look at the two most common situations where you'll use lambda expressions, in LINQ expressions and to define delegates. LINQ or Language Integrated Query is a set of technologies used in C# to query data of different types. LINQ can use query expressions, lambda expressions, extension methods, anonymous types, and various library functionalities. There are two possible ways to query objects using LINQ, using query syntax or using method syntax. Both yield the same result with different syntaxes, as query expressions are converted into a method call and a lambda by the .NET Common Language Runtime, CLR. It is useful to explore both of them when learning about LINQ, but for the purposes of this tutorial, we will only work with lambda expressions using query syntax in C#. Let's look at some examples of lambda expressions used in LINQ. First is expression lambdas. This code returns the number of times that 5 is present in the list numbers. The LINQ query used here is count, which takes a filter expression and counts the items that satisfy the expression. How does count determine which items to include in the count? Using the lambda expression x goes to x equals to 5. You'll notice this lambda expression is a little different from other functions. In this case, the output won't be a number, but rather a boolean. This expression checks whether the given input x is equal to 5. If it is, a value of true will be returned, otherwise false will be the output. This is called a predicate, a statement that, depending on the values of its variables, will be true or false. So numbers. Where x goes to x equals to 5 is saying query the list numbers when the lambda expression x goes to x equals to 5 evaluates to true. Second is statement lambdas. I tend to find expression lambdas, where the body is an expression, like x equals to 5 here, easier to understand than statement lambdas, where the body is a block of code, a sequence of statements enclosed in braces. Let's look at a second example. This example is equivalent to the example we had before, this time using a statement lambda. This time, the lambda expression used inside of the count is x goes to return x equals to 5. Using a statement lambda here is unnecessary, but it is enough to show the syntax. Return x equals to 5 will return a boolean, just like the expression in our earlier lambda. Then the count will count the number of items satisfying the expression. So far, we have seen how lambda expressions are used in LINQ, but they are not constrained to this. They can also be used to create delegates. C# has the concept of delegate, which is a way to describe the type of a method. Action, for instance, is a built-in delegate defined inside .NET that represents all functions with no parameters or return type. Such delegate can be defined like this. Basically, it works by adding the keyword delegate before the template signature of all functions we want to be able to reference. The name used action, in this case, becomes the name of the delegate and, consequently, the name a new type that can be used to reference void functions with no parameters. Let's look at two simple examples, one using expression lambdas and one using statement lambdas. When using expression lambdas, a delegate can be created using the Func class. Square delegate takes an integer as an input and outputs a value of type integer as well. The lambda expression is the same we used for our very first set of examples. The value of the input x will be used to compute the output in the expression x multiplied by x. A delegate can be created in the same way using a statement lambda. Here, the expression side of the lambda is a statement, a block of code enclosed in braces. This syntax can look more involved, but the result is the same. The value of x passed into the delegate when called, and will be used to calculate the square of x. Here are the examples for different operators in LINQ and the equivalent lambda expressions. The where operator filters the collection based on a given criteria expression and returns a new collection. This query sample uses a where operator to filter the students who is teenager from the given collection. It uses a lambda expression as a predicate function. The OfType operator filters the collection based on the ability to cast an element in a collection to a specified type. Use OfType operator to filter the above collection based on each element's type. OrderBy sorts the values of a collection in ascending or descending order. It sorts the collection in ascending order by default because ascending keyword is optional here. Use descending keyword to sort collection in descending order. OrderBy result in this example would contain following elements after execution. OrderByDescending result in the above example would contain following elements after execution. The ThenBy and ThenByDescending extension methods are used for sorting on multiple fields. The OrderBy method sorts the collection in ascending order based on specified field. Use ThenBy method after OrderBy to sort the collection on another field in ascending order. LINQ will first sort the collection based on primary field which is specified by OrderBy method and then sort the resulted collection in ascending order again based on secondary field specified by ThenBy method. The same way, use ThenByDescending method to apply secondary sorting in descending order. This example shows how to use ThenBy and ThenByDescending method for second-level sorting. As you can see in this example, we first sort a student list collection by student name and then by age. So now, ThenBy result would contain these elements after sorting. ThenByDesc result would contain these elements. Please notice that RAM with age 20 comes before RAM with age 18 because it has used ThenByDescending. The GroupBy operator returns a group of elements from the given collection based on some key value. This example creates a groups of students who have same age. Students of the same age will be in the same collection and each grouped collection will have a key and inner collection, where the key will be the age and the inner collection will include students whose age is matched with a key. The joining operators joins the two sequences and produce a result. The join operator operates on two collections, inner collection and outer collection. It returns a new collection that contains elements from both the collections which satisfies specified expression. Let's understand join method using these student and standard class, where student class includes standard ID that matches with standard ID of standard class. This example demonstrates LINQ join query. In this example of join query, student list is outer sequence because query starts from it. First parameter in join method is used to specify the inner sequence, which is standard list in this example. Second and third parameter of join method is used to specify a field whose value should be matched using Lambda expression in order to include element in the result. The key selector for the outer sequence student goes to student.standardID indicates the take standard ID field of each elements of student list should be matched with the key of inner sequence standard goes to standard.standardID. If value of both the key field is matched, then include that element into result. The last parameter in join method is an expression to formulate the result. In this, result selector includes student name and standard name property of both the sequence. Standard ID key of both the sequences must match, otherwise the item will not be included in the result. For example, Ron is not associated with any standard, so Ron is not included in the result collection. Inner join result in the above example would contain these elements after execution. The GroupJoin operator performs the same task as join operator, except that GroupJoin returns a result in group based on specified group key. The GroupJoin operator joins two sequences based on key and groups the result by matching key and then returns the collection of grouped result and key. This example demonstrates the GroupJoin in query syntax. This is the output it produces. This example demonstrates select operator that returns a string collection of student name. The select operator can be used to formulate the result as per our requirement. It can be used to return a collection of class which includes properties as per our need. LINQ query syntax must end with a select or GroupBy clause. This example of the select clause returns a collection containing the name and age property. The quantifier operators evaluate elements of the sequence on some condition and return a Boolean value to indicate that some or all elements satisfy the condition. The all operator evaluates each elements in the given collection on a specified condition and returns true if all the elements satisfy a condition. This example checks whether all the students are teenagers. It produces false output. Any checks whether any element satisfy given condition or not? In this example, any operation is used to check whether any student is teenager or not. It produces true output. The count operator returns the number of elements in the collection or number of elements that have satisfied the given condition. C# query syntax doesn't support aggregation operators, which performs an accumulate operation, like average, aggregate, count, max, min and sum. However, you can wrap the query into brackets and use an aggregation functions like here. We have covered everything for this tutorial. Please like, comment, share and subscribe to my channel for more fun videos, and stay tuned for more. Thanks for watching.